Hello, welcome back. The title here is called Factoring Expressions Part 1. The title sounds complex, but I promise anybody watching this, I can have you understanding this concept in just a few minutes because even though it looks tough, it actually is very simple to understand. I promise you that. So, factoring an expression, you really should think about it as distribution in reverse. You know, we've learned about the distributive property. That's when you multiply everything going on to the inside of the parentheses, right? We've done that a lot. Well, factoring is literally the reverse process. Really, you could call this lesson reverse distribution. That is a better name because it means what we're actually doing, but really we call it factoring an expression. Let me show you what we're trying to achieve here, and then we're going to work our way up to it. Let's say I give you the expression x squared plus x. What I want to do is I want to factor this expression. I want to write this expression as something, you know, I'll put a little box here, something multiplied by something plus something. You see, that's why I say it's reverse distribution, because remember, distribution is when you have something on the outside and you multiply it in, right? Well, in this case, we're starting with the end result and we want to pull something out to the outside and put some parentheses and fill in the blanks here with all the information. Now, before we actually do this, I want to go and backtrack with numbers because it's very easy to understand with numbers, right? Let's look at the expression 2 plus 4. Now, I know that you all know this is 6. That's not the point. The point, yes, it is 6, but that's not the point. The point is we want to write this in a different way. Now, let me show you that 2 is really, this 2 is really here, but then we're adding to it 4, right? But we can always write 4 as 2 times 2. What we want to do here is we want to look at either the numbers, or you can look at the factor, this way of looking at it here, and see what is common to both of these terms. You see, I do have a single 2 here and I have 2 of them here, but when I say what is common to both, I want to figure out what number, later on letters, variables, but what number could I pull out of both of these kind of terms here. I have a 2 here and a 2 here. I can pull a single 2 from both locations and pull it outside of a parentheses. And if I do that, then I have to figure out 2 times something is 2, 2 times 1 is 2, link it with a plus sign, and 2 times something is 4. 2 times 2 is 4. Now, first I want you to stop and look at this and say, well, what is the answer to this? If I give you this, how do we verify that it works out to be the same as this? Well, I can multiply in 2 times 1 is 2, and then multiply in 2 times 2 is 4. So this form is the same thing as this form. This is called the factored form. And in order to get the factored form, all we do is we look at our numbers, or sometimes you can look at the kind of the multiplied versions of this, and you're saying, well, what is divisible? What can I divide both of these by? I can divide this by 2, and I can divide this by 2. And that means that there's a 2 wrapped up in both of these terms. And in order to pull it out, I need to have something common to both terms on the inside. And when I find something that's common to both, then I can pull it out of a parentheses here, and I can kind of write my own parentheses here. And I know that this is divisible by 2, and I know that this is divisible by 2, and this is shown by the idea that I have a 2 that's common in both locations. I can grab it and pull it out. It's like reaching into a box and grabbing something and yanking it out because it's common to everything, every term on the inside, and I bring it out. Then when I write my parentheses, I just figure out 2 times something is 2, it has to be a 1, and 2 times something is 4, and it has to be a 2. And that this form is exactly the same as this, right? You can see 2 plus 1 is 3, 3 times 2 is 6, and 4 plus 2 is 6. So this gives me the same as this. This is the factored form. All right, let's do another example with numbers, and then we're going to go back to our example right over there with the variables, which is what we're really trying to do. What about 6 plus 3? You have to look at these terms and say, what is divisible? What can be divided into both of these? And that would be common to both of them. Well, 6 is divisible by 2, but 3 is not divisible by 2, so there's no 2 kind of wrapped up inside of this. But I can divide this by 3 and also this by 3, so I say that there's like a 3 in common to both of those terms, and I'm going to grab and pull that 3 out, and then I'm going to open my parentheses up. I know I can pull a 3 out because they're both divisible by 3. So the way I wrote it here is just showing you that I can grab this one and grab this one, but I could write this as 2 times 3 is 6. So there would be a 3 in common to both. Now once I pull the 3 out, I just figure out through distribution, 3 times what is 6? Well, 3 times 2 is 6, and I have a plus sign from here. And 3 times what is 3? 3 times 1 is 3. This is the answer. This is the factored form. And you can verify, if you add these, 2 plus 1 is 3, 3 times 3 is 9. And of course, 6 plus 3 is also 9. So this, even though it looks different, is the same as this. Now I know what you're thinking. Why do I care about this? You're going to have to trust me. As we do this with variables, then we're going to get comfortable with that skill. And then as we solve equations later on, you're going to do this business all the time in order to solve equations. With numbers, no, we never care to do this. This is just silly. We would never do this. But when we get to something like this, and there's an equation, the way to solve those equations is first to factor them. This is called factoring. And then we can solve it much easier. So you're going to have to trust me that that's why we're doing it. That's why we're learning this skill. Now let's do one more example with numbers. What about 6 minus 10? Notice there's a minus sign here. Doesn't matter, doesn't stress anybody out. What is common to both of them? In other words, what can I divide in? What's the biggest thing I can divide in to both of these? Well, I can divide both by 2, right? Because 2 times 3 is 6 and 2 times 5 is 10, right? So I know that there's a 2 that's in common to both of them, and I open my parentheses up. I'm pulling the 2 out from this term that's wrapped up inside, and I'm pulling the 2 out from this one that's wrapped up inside to the outside of a parentheses. Now, 2 times what is 6? 2 times 3 is 6. And you link it with a minus sign because there's a minus sign here. Now, 2 times what is 10? 2 times 5 is 10. And so this is it. This is the factored form. Now let's verify that this is true. Is this really the same as this? Well, what does this actually equal over here? 6 minus 10, that's a negative 4, right? Because you can do the subtraction and get a 4, and the sign goes with the larger absolute value. And since 3 minus 5 is negative 2, and negative 2 times positive 2 is negative 4, we verified that even though this thing looks totally different than this, they're actually the same thing. Now that we know how to do this, let's go and solve our problem here. X squared plus x, right? What does x squared actually mean? I'm not going to do this for every problem, but I'm going to do it for this. X squared means x times x. That's what it actually means, right? So I'm looking for something that's common to both of these things. And I have an x here and I have a single x here. Whatever you pull out, you must be able to pull it out from both terms, like we did over here. We were pulling a 2 out because we could pull only a 2 from this and from that. We can't pull 2 of those 2's out because we only have one of them here. We have to be able to pull the 2 out from both terms. Here we pulled the 3 out because it was common to both terms. Here we pulled the 2 out because it was common to both terms. Here we can only pull a single x out because we only have one of them here and 2 of them here. We can only then pull a single x out. Then open those parentheses as usual. Now x times something is x squared, right? X times something is x squared. Well, it's got to be an x. You can see the other x is right there. Then you have a plus sign, and then x times something is x. Well, x times 1 has to be x, and that is the final answer. So you have the answer of x times x plus 1. What we're saying is that this, even though it looks totally different, is actually the same exact thing as what I gave you to start with. Let's verify. Multiplying in x times x, that's x squared, plus x times 1 is x. So it is exactly the same thing, and this is called the factored form. Now you see why I call it reverse distribution, because we can get the answer and multiply in and always check to make sure that we're correct. But instead of doing that, I'm giving you the answer and telling you to do reverse distribution. Reach in and pull out what is common to both terms, the largest thing that you can pull it out, and then write down the factored form. All right, let's cruise along here. What about y cubed minus y? Now we ask ourselves, what is common to both of these? Well, I have a single y here and I have 3 of them. This is y times y times y. So I cannot pull y cubed out because although I do have 3 of them here, I don't have 3 of them here. And I can't pull y squared out because, yeah, I have enough here, but I don't have enough here. I only have 1. I only can pull a single y out because that's the only thing common, the largest thing common to both, right? So I pull a single y out. Now y times what is y cubed? Well, inside here has to be y squared, because when I multiply, remember, same base, I add the exponents. 2 plus 1 is 3. Then I link it with a minus sign, and then y times something is y, and you have to put a 1 here. And so this is the answer. And you can always verify it's true, because y times y squared is y cubed minus y times 1 is y. So you can check your work for every one of these and you'll always know it's correct. You should never guess and say, well, gee, I think it's right. You should always be able to verify. All right, let's take a look at 2a cubed plus a squared. All right, 2a cubed plus a squared. Now, what is common to both? Well, I do have a 2 here, but there's just an invisible 1 in front here, a coefficient of 1. So I cannot pull that 2 out. I want to, of course I want to, but there's no 2 in this term, so I can't pull the 2 out. I could pull a single a out. Yeah, I could do that, but you're always wanting to pull the largest thing out that you can, right? Let's just go and get the answer that we think we're going to get, and then I'll work it another way and show you what happens if you don't choose correctly. I can actually pull out an a squared. Why? Because I have 2 of these a's here and I have 3 of them here. So that's the largest thing I can pull out. Open my parentheses. Now, a squared times something has to give me 2a cubed. What has to fit here is 2 times a. Because a squared times this will be 2a cubed. You add those exponents, right? Then we have a plus sign. And then a squared times something is a squared. There has to be a 1 here. So you multiply in, you get 2a cubed. You multiply in, you get a squared. So you know the answer's right. I don't even have to look at my notes. I know they're right. Now let's see what happens if you don't choose correctly. 2a cubed plus a squared. The largest thing we can pull out is the a squared. Let's say you don't do that. Let's say you just pull an a out instead. Because you say, well, there's an a common to both. I'm just going to pull a single a out. Let's see what happens. So on the inside, a times something is this. You have to have a 2a squared. You add those exponents, you get that a cubed. Next, a times something is this. You have to have an a here. So verify. This times this gives me 2a cubed. This times this gives me a squared. So you say, it's correct. But then you notice, wait a minute. When I look at this, I still have an a over here, and I can have an a squared here. I could actually pull out another a from that. So what you would have is the original a that you had, and then when you factor this expression that you had left over, you can pull another a out. This is multiplied by this, so it'll be multiplied by another a. What would you get here? It has to be 2a in here. This times this gives me 2a squared. You add those exponents. And then you have to have that plus 1 because here a times 1 is a. You see, all I'm doing is factoring this to give me this. But then what happens on the outside? I have an a times an a, which is a squared. 2a plus 1. Notice that's exactly what I got. So when you try to factor, always look for the largest thing you can factor, the most number of variables that's common to both terms, and grab it and pull it out. But if you mess up, then if you don't pull enough out, then you're just going to be left with something that can be factored again. And then you're going to get exactly the same answer. It's just like simplifying fractions. If I have 8/16, I know I can divide top and bottom by 8. But if I mess it up and divide by 2, I'll just get a new fraction that I could simplify again, and I will still get down to the same place. This is sort of the same thing. If I don't choose correctly or perfectly, I can still get to the right answer. All right, let's take a look at 5b to the 5th minus b to the 3rd. All right, what do I have here? I would love to pull a 5 out, but I have a 5 here and a 1 here. It's not common to both, so I can't pull that out. But I do have 5 of these b's. In fact, I need to change that. It doesn't look so clear. This is a b to the 5th. I have 5 of these b's and 3 here. The largest thing I could pull out would be 3 of these b's, b cubed, right? Now, b cubed times something is this. It has to be multiplied by 5b squared. Why? Because when I multiply these, the 5 will be multiplied and give me this, and I'll add these exponents to give me b to the 5th. And then I have a minus sign, and then b cubed times 1 is this. So again, I can check. Multiply in, I get 5b to the 5th, adding the exponents. Multiply in, I'll get a minus b cubed. And so the answer is b cubed, 5b squared, minus 1. All right. Only 3 more problems. Let's say we have 3x squared plus 6x. So now we have the situation where we have some numbers here and some variables. What is the largest thing I could pull out in terms of the numbers? For the numbers, I just say, well, what can I divide into these things? What is the largest thing? They're both divisible by 3. That's the biggest thing I can think of, so I'll pull a 3 out. And for this, what is the maximum number of x's I can pull out? Just one, because there's only one here and two here. So I can only pull out a 3x. Now, 3x times something is 3x squared. I just need to put an x here. Check yourself. 3 times 1 is 3, and x times x squared. Then, this times something is this. I have to just have a 2 there. Why? Because 3 times 2 is 6, and then the x times this is, there's no x there to combine with, so it's just an x. So I've verified that the answer is 3x times x plus 2. Notice that it doesn't appear that I'm doing much work. It doesn't appear I'm doing anything. I'm just writing the answer. That's because to write down anything for these particular problems is hard. I mean, because it's like multiplying. You know that 12 times 2, you know what that is, right? Because you've memorized it and you've learned it, but you know what multiplication is, you know what division is. If I give you a division problem that's easy to do in your mind, you might have to think about it, but there's nothing much to write down other than what can I pull out, how do I multiply? And so the way I'm writing it is actually the way I want you to do it. What about 10y to the 4th minus 8y squared? All right, what is the largest thing I can divide into these numbers? I can divide them both by 2, right? I can't pick 4 because this is divisible by 4, but this one is not. So 2 is the biggest thing I can actually choose here. How many y's can I pull out? Well, I've got 2 of them here and 4 of them here. So I can only pull out a maximum of y squared because that's what's common to both. Now this times something is 10y to the 4th. It has to be a 5 because 2 times 5 is 10. And then y squared times y squared is y to the 4th. You multiply these and you add the exponent. You multiply the numbers and you get this. Then you have a minus sign. And this times something is this. Now you know you have to have a 4 because 2 times 4 is 8. And that's actually all you have because when you multiply this times 4, you get the 8, and then the y squared, you're not adding anything, no exponents to it, so you just get the y squared, and this is the final answer. 2y squared times 5y squared minus 4. Right? Only one more problem. What about 21a to the 6th power plus 28a to the 4th power? All right, what is the largest number I can divide into here? Well, 7 times 3 is 21, and 7 times 4 is 28, so I think the biggest thing I can pick is 7, right? But what about variables? I almost messed that up. What about variables? How many a's can I pull out? I have 4 of them here and 6 of them here. I can only pull 4 of them out. So this times something has to be this. Now, 7 times 3 is 21, so that has to go there. And then I'm multiplying, I have to be over here a squared, because a squared times a to the 4th, you add the exponents, you'll get that a to the 6th back. Then you have a plus sign. Now 7 times something is 28, has to be 7 times 4 is 28. And then you have a to the 4th. If you don't put anything there, you'll still get an a to the 4th back. So check yourself. Multiply this times this, you'll get 7 times 3 is 21. You'll add these exponents for a to the 6th. Then you'll have 7 times 4 is 28, and there is no other exponent to add, so the a to the 4th will go into the answer. So the answer is 7a to the 4th times 3a squared plus 4. So I want you to really look at where we started. We started the journey talking about the simplest of numbers. That numbers, because you can write them as the product or the multiplication of other numbers, it's like there's numbers inside of these numbers. Like whatever I can divide into it, the largest thing I can divide into it, I'm going to choose to pull that out. So I'm going to pull a 3 out from here. I'm going to pull a 2 out from here, and I'll pull a 2 out from here. Once I pull the numbers out, then what goes in the parentheses, it's kind of like when you divide. If I tell you what is 16 divided by 2, in your mind, you're going to think, you're going to reverse it. You're going to say 8 times what is 16? This is you're doing the same thing. It's like you're pulling it out and you're saying 2 times what is 6? 2 times what is 10? That's what you're doing in your mind. And when you change it over to letters, you're doing the same thing. You're saying, well, I can pull a single x out of both of these terms, and then this times what is x squared. There has to be an x there. This times what is x. There has to be a 1 there. This times what is y cubed. There has to be a y squared there. This times what is y. There has to be a 1 there. And so it's very much like the division you learned as a child when, 27 divided by 9, you think, okay, then 9 times what is 27? It's the same thing. So it's called, it's called factoring expressions, but I like to think of it as a reverse distribution. And again, the big picture, why do we care about doing this? It's because later on when we solve an equation, often the first step will be to factor it. And that's going to be the main way we're going to solve lots of more complex equations when we get to that part of your learning down the road. So I'd like you to factor these expressions, solve all of these problems, and give yourself a pat on the back because you went from basic numbers and understanding simple things, to pretty complex looking expressions and factoring. The good news is you always can check your work. Just multiply it back in and see if you get the right answer. And this is why we spent so much time on exponents, because you have to know that you can add these exponents to do any of this stuff. So we did the lesson on basic multiplying of terms where you have to add the exponent without any of this stuff just to get that skill, and now we're using that skill. So we're putting a lot of different things together here, and it does take time to bake in the oven up here. So practice them. When you're getting the right answer, follow me on to the next lesson. We'll continue building your skills on factoring expressions.